the third side. So we know that this is the third side, so C. So for part 1 we're going to use theorem of Pythagoras. C squared is equal to A squared plus B squared. Okay, so that's Pythagoras theorem. Alright, but in this case C is always opposite the right angle. So C squared is equal to 10 squared plus 24 squared. So C squared is 100 plus 576. C squared is 676. So C is the square root of 676, which is equal to, use your calculator, 26 centimeters. Okay, so then for part 2, the perimeter, you add up all the sides. So there are 3 sides on the triangle, so the perimeter is equal to 10 centimeters plus 24 centimeters plus 26 centimeters, which is equal to 60 centimeters. Okay, now I'm just going to put it here as well. They didn't ask for it, but if you were asked for the area of the triangle is equal to half the base by the perpendicular height, which in this case would be a half of 24 centimeters multiplied by 10 centimeters, which is 12 centimeters by 10 centimeters, which is 120 centimeters squared. But that's just extra for you, okay? You weren't asked for that there, okay? Now, for part B, this one is pretty tricky because you have to do all the work, okay? So, you need a ruler. In order to estimate the area of the shape, a horizontal line is drawn across. So that's horizontal. And the widest part of the shape, 3 offsets. So these are the 3 offsets are drawn at equal intervals along this line. So we want to measure the horizontal line and the offsets. Okay. So the first thing we're going to do is measure the horizontal line. So the horizontal line, using your ruler, is 12 centimeters. Okay, so for part 1 then, the horizontal is equal to 12 centimeters. Okay, so therefore, if this is H will be equal to 12 centimeters divided by 4, which is 3 centimeters. Okay, so H will be 3 centimeters. Okay, now we want to measure the offsets. So this here, let's measure. So that's 2 centimeters, and down here it's 3 centimeters. Up here is 5 centimeters, and down here is 2 centimeters. Up here is 2, and down here is 2. Okay, so there are our offsets, and we've recorded our measurements. Okay, for part 2 then, we're using trapezoidal rule. Okay, they took Simpson's rule off the leave insert a couple of years ago. So it's H over 2, first plus last plus 2 times everything else. And the everything else is the key. So we don't include the first or the last the second time. So in this case we know that H is 3 centimeters. The first is 0 centimeters and the last is 0 centimeters. So H is 3 centimeters over 2. You know the first is 0, the last is 0, and it's 2 times everything in between. So 2 times 2 and 3 is 5 centimeters, 5 and 2 is 7 centimeters, and 2 and 2 is 4 centimeters. So everything in between. So that's 1.5 centimeters multiplied by 0 centimeters plus 2 times 16 centimeters, which is 1.5 centimeters multiplied by 32 centimeters, which is equal to 48 centimeters squared. So that's roughly the estimate for the area is 48 centimeters squared. Okay. Now you have to make these measurements up, so just be careful and read the question carefully. So read carefully. Okay, that's important there. For part C, a trophy for the winners of a football match is shown, and it's a sphere on top of a cylinder. So we have a sphere up here and we have a cylinder here. Okay, so we want to find the volume in terms of pi. So we're going to leave pi on its own. So the volume of the sphere formula is 4 over 3 pi r cubed, which will be 4 over 3 by pi, and the radius won't be 21. The radius will be 21 over 2, which is 10.5 centimeters. So it'll be 10.5 centimeters cubed. So 4 over 3 multiplied by 10.5 cubed gives me 1543.5, and we include pi centimeters cubed, and that's the volume of the sphere. Okay, now part 2, the total volume of the trophy is 6174 pi. So the trophy is equal to 6174 pi. We know the sphere is equal to 1543.5 pi. So we're going to take those away, and we get 4630.5 pi centimeters cubed. So that's the volume of the cylinder. Okay? Now what's the formula for the volume of a cylinder? The volume of a cylinder is equal to pi r squared h, which in this case, pi multiplied by, the radius is 10.5 squared, times h is equal to 4630.5 pi. So cancel the pi's, and we're left with 10.5 squared is equal to 110.25 times h is equal to 4630.5. So h is equal to 4630.5 divided by 110.25. H is equal to, so 4630.5 divided by 110.25 is equal to 42 centimeters. So the height of the cylinder is 42 centimeters.